I am Dr. A. Kalai Selvi. Today I present the topic Overview of Expert System. The types of expert systems are role-based, case-based, model-based and hybrid-based. Then the next is the user interacts with the system through a user interface. That is, that simplifies the communication and hides much of the complexities, such as the internal structure of the role-based system. Then the expert system interfaces employ a variety of user styles. That is, user style includes question and answer, menu driven or graphical interface. Then the final decision of the interface type is a compromise between the user needs and the requirements of the knowledge base and the inferencing system. The heart of the expert system is the knowledge base. Knowledge base requires that it recites some of the informations which contains the knowledge of a particular application domain. In a rule-based expert system, this knowledge is most often represented in the form of if-then rules. The knowledge base contains both general knowledge as well as case-specific information. For a particular problem, the inference engine applies the knowledge to the solution of actual problem. It is essentially an interpreter for the knowledge base. It is done one by one. In the production system, the inference engine performs the recognize and act control cycle. The procedures that implement the control cycle are separate from the production rules themselves. It is important to maintain this separation of the knowledge base and inference engine for several reasons. This separation makes it possible to represent knowledge in a more natural fashion, that is, if-then rules. For example, the rules are closer to the way in which the human describe their problem-solving skills than is lower-level computer code. That is, because of the knowledge base is separated from the programmer's lower-level control structure, expert system builders can focus on capturing and organizing the problem-solving knowledge rather than the details of its computer implementation. Ideally, the separation of knowledge and control allows changes to be made in one part of the knowledge base without creating side effect in others. The separation of the knowledge and control elements of the problem that allows the same control and interface of the software to be used in a variety of systems. The expert system must keep track of the case-specific data, that is, the fact, conclusion, and other information relevant to the case under consideration. These parts includes the data given in a problem instance, that is, partial conclusion, confidence measures of conclusions, and dead ends in the search process. These are all the information. That information is separate from the general knowledge base. Many systems also include a knowledge base editor. That is, the knowledge base editor helps the programmer to locate and correct the bugs, that is, errors in the program performance. That is often accessing the information that are provided by the explanation of the subsystem. They also may assist in the addition of new knowledge in the knowledge base. That helps maintain correct role, that is correct rules means that is the syntax of the system, and performs consistency, that is checks on any updated knowledge base. Then an important reason for the decrease in design and deployment times for current expert system is the availability of expert system shells. That is NASA has, that are the examples. NASA has created clips. This is available from the Sanita National Laboratories. Expert system involve a considerable investments of money and human effort. Attempts that are attempts to solve a problem that is too complex, too poorly understood, or otherwise unsuited to the available technology, that can lead to costly and embarrassing failures. Then the researchers have developed guidelines to determine whether a problem is appropriate for expert system solutions. This is the need for solution justifies the cost and the effort of building an expert system. That is, many expert systems have been built in domains such as mineral exploration, business, defense, and medicine, where a large potential exists for saving in terms of money, time, and human life. Human expert is not yet available in all situations where it is needed, that is, the human experts are available. In geology, for example, there is a need for expertise at remote mining and drilling sites. Often geologists and other engineers find themselves traveling large distance to visit sites, with the resulting expense and wasted time. By placing expert systems at remote sites, many problems may be solved without needing a visit. The problem may be solved using symbolic reasoning. Problem solution should not require physical dexterity or personal skills. Robots and vision systems currently lack the sophistication and flexibility of humans. The problem domain is well structured, that is, it is defined by all needs, and does not require common sense reasoning. Highly technical fields have the advantages of being well studied and formalized. Terms are well defined and domains have clear and specific conceptual models. That is, each model have been defined well clear and yes, well specific defined definitions. In contrast, common sense reasoning is difficult to automate. The problem may not solved using traditional computing methods. Expert system technology should not be used where unnecessary. If a problem can be solved satisfactorily using more traditional techniques, then it is not a candidate. Cooperative and articulate expert exist. The knowledge used by expert system comes from the experience and judgment of humans working in a domain. It is important that these experts be both willing and able to share knowledge. The problem is a proper size and scope. For example, a program that attempt to capture all the expertise of a medical doctor would not be feasible. A program that advises MDs on the use of particular piece of diagnostic equipment or a particular set of diagnoses would be more appropriate. Thank you.